Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video, I would like to discuss or explain about the orbital overlapping. So before we discuss further about the orbital overlapping, so the concept of the orbital overlapping is used to explain the covalent bond between atom in a molecule. So let's say we have a hydrogen gas. So we know that hydrogen gas form when two hydrogen atom combines together and share the electron. So it will form a hydrogen molecule. The concept of orbital overlapping is to describe how the electron shared overlap between each others. Right? So because of that, in this part we will explain how the orbital overlapping form. Right? So there are three types of orbital overlapping. So let's say it is between the s orbital with another s orbital. It will form like this, or the s orbital overlap with any p orbital. It will form like this maybe, or a p orbital overlap with another p orbital and it will form this. Okay. There are two types of bond formed from the orbital overlapping. The first one is, we call it as a sigma bond, and this is the symbol. And the second one is pi bond, and this is the symbol. Right? So what is the difference between these two? The sigma bond is a bond formed when the orbital overlap end-to-end overlapping. This is an example of the sigma bond. This is an example of sigma bond, which is end-to-end overlapping. But the pi bond is the overlapping side by side. This is an example of pi bond. Okay, so this is the first thing that you have to understand before we discuss further about the orbital overlapping. Alright. Next, we will look at the types of orbital overlapping. So we have two types. The first one, we call it as a pure orbital overlapping. What does it mean by pure orbital? Means that the overlapping involve its original orbital. Let's say if it is an s orbital, it still form, or it is still in a form of spherical when it undergoes overlapping. If it is a p orbital, it's still in a form of dumbbell when it undergoes overlapping. And the second part, which is the commonly occurs during in a molecule, which is a hybridization. Okay, hybridization means we have an orbital, we mix together or we blend it together, and it will generate a new set of orbital with the same same energy level. Okay, so so now I will explain about the hybridization. So what does it mean by hybridization and how it occurs? Alright, so as I mentioned previously, it is a process of mixing two or more orbital to produce a new set of orbital with the same energy level. So let's say we have, this is an example. Let's say we have 3s orbital, we have 3p orbital, Okay, 3s and 3p orbital. If we can see, there is a gap between it. It shows that the energy level between 3s orbital and 3p orbital is not at the same level. So when it undergoes hybridization, there are three possibilities of hybridization product. Okay, when we hybrid, let's say for the first one, I only hybrid one of the orbital s and one of the p orbital. So the product is sp orbital. If you can see, each box are on the same level because there is no gap between it. So we call this as a hybridization that produce an sp orbital. The second possibilities is when we take one of s orbital with two p orbital. At this stage, we will produce this hybridization will produce sp3 orbital. sp2. How I get 2? S equal to 1, P ada 2. Alright, so how to interpret this box? This orbital represent sp, this one also sp. But for this one, this is sp2, this is sp2, this one also sp2. Okay, and the third possibilities is when we mix or blend one s orbital with another 3p orbital, and the product is, this is our product. We have 4 s and another. This is sp3 orbital, right? So kita ada 3 dah sekarang. And what happened? We have a combination with 3d orbital. Okay, so let's say I add another orbital. We have 3s, we have 3p, which is at the same different energy, and we have 3d. Okay, the maximum that we can hybrid is, let's say we take one of the s orbital, p orbital, and 1d orbital. So in this case, our product is sp3d. Okay, and the last one is if we take one of the s orbital, 3p orbital, and 2d orbital, like this. And at this time, our product for this hybridization is called sp3d2. Okay, so this is the maximum orbital that we can blend or hybrid it together. Alright, so the remark that you're supposed to remember or you're supposed to understand is, if it is an sp orbital, the shape is linear. If it is an sp2, it is trigonal planar. If it is sp3, it is tetrahedral. If it is sp3d, it is trigonal bipyramidal. And the last one is octahedral. Now, what about the shape of the orbital when it undergoes hybridization? Okay, adakah dia kekal sebagai dumbbell, or it still remain as a spherical, or it produce anything else, another shape? Alright, So in terms of the shape of the orbital after it undergoes hybridization, so let's say when we mix together s orbital, we mix with another 1p orbital, the product is called sp orbital. And the sp orbital does not have the identity of spherical or dumbbell. The shape is like this actually, in the form of loop. This is sp, and the another one also produce the same. This is one, and this is the one. And because of that, we use this diagram to represent the sp. So one loop is sp, this is also sp. So we have two box, so we have two loops. What about sp2? Let's say we have one s orbital hybrid with another 2p orbital. So the product is sp2 with the shape of 1, 2, 3 because it is a trigonal planar. Okay, same goes to the others. sp3, the shape supposed to be tetrahedral. sp3d, the shape supposed to be trigonal, bipyramidal and octahedral. sp3d2. Okay, so I think for the general statement ni, we will stop here, and after this in the next video I will show you the example of sp, sp3, sp3, sp2 and so on. Right, so assalamualaikum.